Hello, this is the final video in our part 4 of series. I hope you are excited. We are going to build our regression model. We're going to use linear regression in this case. So in the previous video, what we did is we got this far. We got the columns that we need for our analysis. So we just filtered the columns that we required. That's what we did. So we are done with that. Then before building our model, we're going to use a partitioning node. And the purpose of the partitioning node is to partition the data. Part of the partitioned data will be used for training purposes and the other partition will be used for testing purposes. Let's take a look at this node. So right click on this or double click and you will see that by default this node will select 70% of the data as your first partition and 30% as your second partition. Okay, and typically what we do is we use our first partition, which is your 70% of the data, for training purposes. So that's what we are going to do here. There's a few other things that you can do on this node, but for now let's not worry about it. We'll just focus on keeping this simple. So 70% it is, and we're going to go ahead and apply this and run this. And so what it's going to do, it is going to create uh, two partitions. So one, the 70% of the data, the other 30%. Now we are ready to use our linear regression learner node, which you can find here in your node repository. So just say linear regression and you will be able to find the node. So in this case, we already have the node here, and let's see how to configure this. Remember, our target variable is miles per gallon. That is your dependent variable in this case. And these are all your independent variables that you are going to use to build the model. Okay, that's that. There's nothing complicated here. That's very simple. This is your target variable. These are your independent variables. And we're going to build the model with this. And you're going to go ahead and execute this. And once you execute this, you will be able to see that it has created a model. And in short, just keeping it simple, you will see an R square of 0.71. Don't worry about adjusted R squared just yet. But if you just focus on R squared, it's 0.7189. It means that about 71% of variability is explained by this model, or in other words, it's about 71% accurate-ish. So now let's use this predictor node. So again, you can get it from your node repository. Use this node, and in this, you will connect your model. So this is your model. You will connect from linear regression learner, the model that it built, to your predictor. And then you're going to use your test data and connect it to your predictor. And then simply right click and configure or double click on this, and you will see there's nothing much to do here. It's going to create a column and it's going to name it as prediction slash in parentheses MPG. That's it. And then you run this, and when you run this, you will get your predictions or your predicted data based on the model you just built. So you can see in here, this is miles per gallon. This is the actual value, okay? And this is the value that your model created, which is pretty close. And so if you look at the others, you will get the same. So this is your actual data, and this is your predicted data, all right? There's another node that we got to use, which is the scorer node. Scorer node. This is the node that will give you the score of your model. So double click on this and you will see that your reference column is miles per gallon and your predicted column is prediction miles per gallon. Pretty intuitive. And then there's one other thing that I have done, which is I have changed the value from 1 to 7 as far as number of predictors are concerned, so that I can get a better adjusted R square. Adjusted R square is good, and it's used and gives a much more accurate idea of how good your model is, because it takes into account the the number of independent variables you have chosen to build the model, and then adjusts it and gives you the better accuracy. Okay, so we look at the statistics here, and then you can see that your R square is 60.699 and adjusted score R square is 0.681, which is fine. That means about 68% of is roughly 68% accurate, which is fair enough. Um, Mean absolute error, mean square error, these are the things that are also used, which we can discuss in another video. So there it is. You have built the model using all the nodes in KNIME without writing a single line of code, and it's pretty intuitive and simple. Hopefully this was a good learning experience, and we are going to continue to build other models, so please stay tuned. Thank you.